Adit, now you first.
Okay. So can can you guys all hear me, right? Like, good.
Like you can like comment the client here. There's a lot of
Okay, so I'll start. So, hi guys, I'm Adit. I work as a software engineer at Grofers. Like one of the things that we kind of really focus on at Grofers is that the software engineering team is also the DevOps team for their products, right? So we kind of follow the policy of like our infrastructure team not doing deployments for not doing operations of the applications on production for us. Instead, we try to focus on building tools which enable development teams to move around their applications in production quickly, right? So I just wanted to kind of gauge the audience, like how many people are aware of containers, what they are like. Okay, and how many people do deployment on a regular basis of their own applications? And like, do you guys use AWS? Like what is your deployment pipeline look like? Uh,
we have like VMs.
Okay.
Which we request.
Okay.
It's not production like the Docker or Kubernetes is production.
Okay, so you guys use EC2, like
No,
you
it's,
some.
it's use Twitter card.
Okay.
Backend network.
Okay, cool. So you guys deploy on some virtualization
Yes.
layer and like does everyone else also do similar things?
We use Ansible.
Okay. Yeah. So even we use Ansible still. Like we're kind of moving towards Kubernetes, but we also like Ansible's great. We love using Ansible. And what about does anyone do things with SH scripts like bash scripts which like pull projects into?
We have our in-house server, so we use
Okay, so how would that deployment work normally?
normally just like we create a new and just report meetup. So there are
Okay, fair enough. So I don't know about you guys. So one of the things that came up for us, like when we are doing all of this, is that it like as your services and your teams grow and increase and stuff, it becomes really hard to manage this, right? Like if everyone is writing out their own way of doing deployment with like they're writing custom bash scripts, like it's like maybe only one person knows how to deploy this, and like or you kind of like or if you're is anyone running like a big monolithic application somewhere, right? So these things have like like doing one small deployment requires a lot of planning, and like if you kind of make a mistake, like, you your suddenly your entire application is broken in production for a long time. And so this is your production environment, right? Like similarly, like you also have, so the other thing is you probably also have like a staging environment where staging and test environments where like you want your developers to push code and iterate on that a lot. You maybe run automated test cases, etc., etc. And even below that, you even actually have the developer's own machine, right? Like you kind of have to figure out how exactly is someone going to like how many people have faced this problem that like they followed the README and stuff which someone has specified on their application, and like you try to run it and for some reason or the other it's not working on your computer. Like, this is pretty regular, right? Because so the general nature is that like running applications, you have a lot of weird dependencies. Like you might require a specific version of the OS to be running specific versions of the libraries which the uh, which the entire like application is depending on. And if you have like hundreds of applications which are working like this, like setting up your production environment, setting up your production environment is like a very hectic it's a very hectic activity, right? You do it once, you try to never do it again, right? Like you kind of try to keep incrementally improving it, but you don't really want to set up production machines again if you can avoid. Right? And this kind of like creates a big limitation, right? Because like so, for example, one of the things that can happen with us in Grofers is that like we kind of really needed. So we were preparing for our one of our biggest sales, right, in January, and like the concerns were that like are we provisioned at the correct capacity to handle the load that's going to come during the sale, right? And that like you can kind of do load tests on stage and stuff, but that's not really going to give you the type of numbers you're trying to get that you might get in production, right? Because in production you're provisioned slightly differently from how you've done things in stage. And what we actually wanted is like we wanted a complete copy of our production exactly as it is in another environment where we can kind of bombard it and take it down, right? And this requires us to basically be able to move our entire production environment anytime we want, anywhere we want, right? And so that is kind of the some of the main motivations why we looked at Kubernetes. And like currently, like one of the workflows that we kind of try to build out with it is that like if you're a developer at Grofers, like we try to give you enough tooling that like you can kind of spin up your own instance of the entire Grofers cluster for yourself, deploy your applications there. Whenever you're done, you can just delete it.
So do you have some diagram for this?
Yes.
Because that will explain a couple of things. So that
Yes, so I'll build up to it. Like, so I'll kind of talk about like, so the overview of the talk, which like I wanted to focus on, was that like, what is Kubernetes? Has anyone heard of the term before? Right? Why do you want to use it? What are the basic concepts that you can just go and look at right now, so that you kind of like so there Kubernetes has like a lot of things, but mostly like if you focus on 2-3 things, you will cover like 80% of most of your use cases, and that will actually get you started really quickly.
How it differs from Docker?
Yes, I will. Okay, so it doesn't differ from Docker per se. Docker is
That's
a
a feature.
yes. Okay, cool.
So
Yes.
I have one question. Could you give us a sense of scale at Uber in the sense of because how many machines are running in production?
Okay.
Ballpark, like is it 1,000, tens of thousands?
It's not thousands. Like also we would be somewhere with, like I think last I checked we were probably running like 700 machines.
700.
Yeah.
what is the typical spec of a given PS?
So those are very application specific, right? Like we like small microservices we might be running on like maybe very small 2 GB 2 GB RAM 4 core machines, and like we might have
They're in AWS.
yes yeah, so we're on AWS.
700.
Yeah, and we might also be there might be some app like so for example we have like one centralized database which is just running a really massive server. Yeah, they're very application specific.
Database is not distributed.
We have a whole bunch of like we have one main database which like a lot of information is there, but microservices have their own databases as well.
Search and
Yes.
Elasticsearch, etc.
Yeah, we use so we do our own Elasticsearch. Like we run our own Elasticsearch on
So
GCP.
transaction data would be flowing through the pipeline to the Elasticsearch environment.
Depends. Like so, it depends. Elasticsearch we currently use mainly for only the
Product search.
yes. We don't and our centralized logging infrastructure, not really for this. And what are the use cases that we were excited about for Kubernetes? The main thing that like there are really good concepts in Kubernetes, which so 700 machines is not really a lot. We're not actually looking at Kubernetes for solving our scalability problem, but we're kind of looking at it as solving the problem of scalability as teams grow, right? Like because it actually helps with that a lot as well. So
So you are saying it is more of a development process problem than the DevOps problem, production problem.
So Kubernetes is actually for the DevOps problem. We're saying that like we found use cases for it where it actually helps our development process a lot as well. And
So
like
you are saying somehow CI/CD becomes far more streamlined if you are using Kubernetes.
yes, it actually does. So for example, like what we like, for example, what our CI environment looks like would be that like when a pull request comes in for a particular application, it gets containerized. Like we've written the code, like the small code for containerizing the thing. It creates a completely fresh environment for that branch, deploys the entire environment there, runs test cases, uh, pass, fail, etc. Then deletes that environment.
So are you using a Atlassian-based framework for managing some of the source code and continuous integration?
No, we're using GitHub and Jenkins.
Whatever.
We try to not use managed services for a lot of internal things because
Okay.
we find that like we like things like Ansible and Kubernetes and stuff because they help us build out our own things. We don't like the limitations of most managed products, which eventually show up at some point. Like some use case we're not able to solve with that, right? Uh, so generally, like EC2 deployment would generally look like this, right? Like you probably have like some CDN server for your front end code, like or content, and the application requests are actually coming to a load balancer. They're going to your EC2 machines. EC2 machines. They are your VMs. They probably have something called the auto scaling group, which you configure it on how the VM should scale up, scale down, and at the back end, like you probably have some persistent store, like your database or something where actual application data is being stored. And this is what an individual service would look like, right?
You are using Postgres SQL for the transaction database.
For some services, yes. We're also using MySQL and Mongo for different services. Like it's totally dependent on, like how we kind of give that autonomy to the teams on what services what services they want to use. But Postgres is like something we like a lot. Like we do use Postgres a lot because it's nice. And the thing which happens is like probably you as a like how many people actually like okay, so I mean not everyone is doing deployments, but the people who are doing deployment, like mostly we focus on the EC2 part, right? Like we kind of focus on provisioning the EC2 part of the thing, and we don't actually focus on the other parts of the application. Like probably you've configured your ELB once, or someone with infrastructure access is configuring your ELB, etc. And probably your database also you're not actually bringing up, you're not actually provisioning those things.
What are the rules for you to, let us say, instance, create a new instance?
What do you mean? What are
So
the
let us say I define auto scaling. So
Yeah.
auto scaling we have to define when a new instance should be created.
Yeah. So again, they are depending on what kind of traffic you are expecting, right? So we kind of do it on the like it. So we do it either on the surge queue of AWS, like we seeing this much requests are waiting, so we start provisioning, or we see like if CPU traffic and memory traffic is going up, like we provision on that. You have to figure out which metric is the load metric for your application specifically. Right. So so this is what a traditional deployment on AWS looks like. Now, the good or like any kind of cloud tool is mostly similar to this, right? And now the thing is with Kubernetes, it actually doesn't look too much different. Like the only thing that you're kind of caring about is that instead of like instead of each of these things being like very specialized resources from your cloud provider or AWS, like they're mostly like things that can be defined by containers and some components in Kubernetes, right? And like there are benefits to doing that, and we'll kind of get there. So before we can start on Kubernetes, right, we kind of have to discuss containers, right? So basically, like what containers are basically they're your VM without running the OS layer, right? Like what they're so when you are running a virtual machine, like so when you are running a virtual, like you have your physical bare metal physical hardware on top of which you're probably running what your virtual machine is doing. It's running a fully provisioned like Linux OS or Ubuntu or Windows or something, and then your applications are going inside that virtual machine, right? And the thing with the thing that you try to do with containers is that like on top of your physical hardware you have one operating system, right? And on that operating system, you basically like in Linux, you have this thing called LXC, what is it, namespaces? I forgot. Uh, so you have a way of separating basically you have a way of separating like how applications inside your OS have access to resources of that OS. So this was a feature that was built in Linux to kind of allow you to run allow you to run applications where you are not sure about how its security access to the security access to the overall kernel is not exposed, right? So what they developed was like you have a way of like separating small spaces for those things, and you can allocate resources to them, and they will execute on the kernel, but they will not actually they're only restricted to restricted to the things that they can use, right? So based on this feature built on Linux, the whole thing happened that okay, like I can actually run complete applications this way, and this ended up becoming something called the container. And like the Docker image format is like the Docker was the first company to kind of experiment with that, and they formed this thing called the Docker image format, which allows you to kind of define how your applications are going to execute in that namespace. So, so that is how the containers work, right? Like how they differ from VMs is that in a VM you are going to run like on your physical hardware. Like it's very expensive to run to run a VM per application, right? But on the same physical hardware. But on a container, because your OS layer is the same, you're actually only containerizing the parts which are running your application. So they become really lightweight, right? And because you're given the guarantee that like they cannot access resources of each other, it is as good as running them in isolation. It is always running those things in isolation. Right? So yeah, so like how many people use Python or Java or Node? Like what do you guys use like Python? So in Python you probably use something called virtual env, right? Like to separate out your environments. Yeah, and this is kind of something you kind of want for not just for Python, right? Why do we do this for Python, right? Because different application packages start conflicting if you install them all on the global Python, right? So similarly, like we kind of want that separation for everything, right? Like because I might be having an application that is specifically depending on say like Postgres 9.6 or like Postgres 8 or something. It's a legacy application, but I need to run it on my computer. I've installed Postgres 10, but if I can't, I now somehow have to manage both these things, right? So these kind of separation of concerns like show up on when you're trying to run multiple applications at various points, not just related to Python, right? So containers kind of offer a generalized solution. So you can just package an entire application, and what you're trying to package is actually like the runtime in which the application is going to be executing, right? Uh, so yeah, so like the language runtime, what version of Python you're using, what are the external libraries you depend on in the OS, like uh, the libraries similar to Django and things, and all those things you can package into a container. And in the container, you don't have to do virtual env because you should be running because containers are so cheap, you should be focusing on running only one, just one application per container. It is very cheap for you to run like lots of containers in your machine. Right? So you kind of make sure that that is the separation. Yeah.
Two applications, one Python 2.7 and 3.4.
Yeah.
And those we run separately.
Yes.
Containers.
Yes.
And then how does the underlying, let's say, we call it compiler or
Yeah.
the syntax, everything changes. So how does the container take care of?
So you should not put them both in the same container. You should be running one container with Python 2.7, one container with Python 3, right? And what will happen is that container, like for the scope of that, like the say the 2.7 container cannot actually see the other, like it is not installed on the global namespace, right? It is actually in its own, it is in its own namespace. It cannot see that there is a 3.4. It has no access to seeing this, so it cannot actually execute that.
Let's suppose you basically forward out development.
Yeah.
And all those kind of things get mixed up in terms of if developers are developing upgrades to both these versions.
Yeah.
So how do you kind of keep them separate? Because people have access to both containers. Let's say development.
Yeah. So one is that containers are all. Okay. I missed the point that containers are immutable, right? So basically, like when you're creating your container, you're pushing a version of your code there. So your container is only containing that thing, right? If you're upgrading your code, changing some things and stuff, you should be making a fresh container out of it, right? Like you don't like so this so the advantage of this is that basically like because your runtime is now immutable, like if say you upgraded your code and stuff to a different version and somehow in production you see this is breaking, right? And say you had to install a bunch of libraries to get that to work. So now what you might have to do is like to roll back, the rollback might not be simply just rolling down a commit and doing it, right? But you might actually have to go and uninstall packages, install the correct packages, blah blah blah, and get all that to happen to make sure your rollback runtime is working correctly. So with containers, because the entire runtime is packaged and immutable, I package the whole thing, I run it. If it's not running, I can just go to the other version of the container which I know is running. Like one version of the container which I've frozen as running is always guaranteed to keep executing in exactly the same way. Like it will never install a new library or do an update inside the thing unless you actually go and manually, like it is still just running Linux inside, but so you can go and do those things, but you really shouldn't. Like you should not be updating you should be making new containers whenever, like making new images. It's very like the way containers are built are also like they're built in layers. So things that you've done, like things that you've done before, which were heavy tasks, they are just reused every time you rebuild a new container instead of actually like doing the whole thing from scratch every time. So kind of helps with that, right? And so the like so the so like so for example, like this with containers alone, you can actually get a lot of developer productivity, right? So for example, like maybe 2 years ago, like we were running Python, like we're running a lot of Python code, and like people coming to my team, like I would have to probably spend a day sitting with them and getting their entire setup done. And like today, like if a new person joins my team, like I kind of just give them the Docker file, tell them to install Docker, run this thing, and like it's done. Like you can your entire environment for your local development is also set up in like a few minutes, and I know that it will. And I can like reliably say that it's working because it's exactly the way that I've configured it to do. Right. Uh, so now that you have like so did everyone get the idea of what containers are? All those things. Yeah. So if you have containers, right now it's like you probably want to, like the thing is you want to run these containers in your production environment or in whatever, like you want to run them in the cloud, right? And generally we've been using VMs. So one way would be to like in your VM you install Docker and you kind of pull your containers and you run them. And that is also like a totally doable solution. Like we've done that sometimes for applications before where we didn't actually want to spend time installing them on the server. And that can work, but like there's actually a better solution, which is like so what you actually want is like you want to be able to orchestrate your containers. That like I want to run this. Can something just make this run somewhere? Point uh, like define my auto scaling group on the containers. so that like if I'm facing load, increase the number of containers that are running and distribute traffic amongst them. Various use cases like that. That is kind of what that is the main selling point of Kubernetes. Right? So Kubernetes is mainly for Kubernetes is mainly for abstracting out the physical hardware which you're running, so that you can kind of deploy containers on it. Right. That is the main use case for it. And what this is kind of small. So okay, so what you probably have is like you have a cloud where you're running multiple VMs, multiple physical nodes, right? Like at the end of the day, one node is there's a limit of how big a computer can get, right? You can probably get a 256 GB RAM thing, and that's probably the one of the max size VMs that are physical nodes that you can get, and probably that is not going to be enough for you to run your entire distributed application on, right? And so what Kubernetes does is like it's basically split into like it basically does you basically tell Kubernetes that I want to run this application in this spec, and what Kubernetes has is that it has control over physical hardware nodes, right? So there is a master and slave concept. Like there are Kubernetes masters and slaves, and what the master will try to do is what the Kubernetes orchestrator will do is that it sees your spec and it will actually deploy your containers to whichever physical node it thinks can handle your capacity, and that's kind of all it that's kind of the main thing that it does. So yeah, it basically tries to schedule your activity on the pods, on the nodes, and it lets you do this in a declarative, right? So you don't actually you don't need to necessarily like um, so one of the things which we experience is like a lot of infrastructure provisioning code looks like a step-by-step concept, right? Like even things like Ansible and stuff are like, even though it's very declarative, it's actually executing in steps, right? And if you kind of try to do those steps, if someone makes a mistake and does a step out of order, it can kind of mess up the deployment process, right? So that is kind of like a bit against the thing of how we do how you want to do things in Kubernetes. Like you kind of want to declare your resources, and what the orchestrator will do is it will actually identify what are the changes it needs to do to move from its current state to the declaration that you've defined, right? So you could say that like you've deployed your container and you've said that I want to deploy with 2 GB of RAM, right? And then after some time you decide that, okay, I want to increase this to 4 GB of RAM. So you kind of say, I want this to be 4 GB of RAM. What the orchestrator will do is it will see that, okay, these are the pods that have been allocated 2 GB of RAM. I'm going to allocate new pods with 4 GB of RAM and re-provision containers there and kill off this thing. And it will do that for you. And if multiple things are kind of competing, and say one of your physical nodes go down, right, or one of your nodes go down and you've lost all your containers, the orchestrator is getting that information that like this is the cluster state, this is what it should be. So it starts to provision new things to heal itself. Right? So and that's like the usefulness of being immutable, right? Like if you were if you have to just declare how much you need, the cluster will make sure that you are always even if it faces troubles and stuff, it will try to make sure that you are always at the state that you've declared that you want to be, right? Yeah. So this basically allows you to move really fast, right? And these are mainly the things that I was talking about before itself. So the main concepts which are there in Kubernetes is like so the most so we'll like so it kind of looks very similar to the way that so you can kind of skip a lot of the terms that I've defined. Like I'll kind of point out which are the main ones that you'll probably want to focus on so that you can get yourself started which would be these two things, like the pods and the services, right? So basically the smallest thing that you want to run is a container, right? And in Kubernetes, like the smallest thing is called a pod, right? The smallest unit of compute is basically is called a pod. And the reason it's not a container is that sometimes you have cases where you actually want to run two applications that are kind of dependent on each other in the same in the close proximity, right? So this could be something like maybe you have maybe you have a Django server and you want to run an Nginx controller on top of that in the same EC2 machine. Maybe that's how you do it. So you want those two containers, like you want one container handling Nginx, one container handling Django, and you want them both to always be on the same node next to each other, so that they can, so that they don't have to do a network hop to talk to each other.
Would you actually put them in the same process? And I assume
No,
it's
so
like sidecar applications.
Yes, so you should not be putting, so you should not, like, you can, there's nothing really stopping you from
No, I
putting
mean in
them
terms
into
of
this.
this practice.
So we've actually had that problem where we put things in the same container, and generally what happens when you put things in the same container, it becomes really hard for you to, like it becomes as good as you running a VM, and small things caching here and there, you don't actually get to recover from that. Right? But if you run them as sidecars, like say you're facing a problem in your in the side application, if it goes down, you know immediately that this is the part that has crashed, so you can heal that part. So it's generally a best practice to keep your application in just one single responsibility for each container, right? So this is the thing called the pod, right? What you do, so there's a way to deploy a pod. Like I'll give a demo of the whole thing after some time. So you kind of declare pods, and what you need is so one of the things in Kubernetes is that these pods are not going to be visible outside the cluster on its own, right? Like you actually need to expose dedicated things to say that these set of pods have to be visible via this port of the cluster, like because but everything is visible within the cluster, right? So
How do pods discover each other?
yeah, so there is something called there is a Kubernetes DNS, like it is inbuilt into the cluster, and they can so if you name a pod, say say user, say you named your container user container, and let's say order container. Let's say these are two services, your user and order. Within the cluster, they can refer to each other. They can also be separated by namespaces within the container, within the cluster, but they can just talk to each other by the name of their service. So, pods of the same deployment can discover each other through the Kubernetes DNS, and pods of other, say you have two deployments, you have a consumer deployment and a orders deployment. They can also talk to each other via the Kubernetes DNS, and their names are whatever you have put in the configuration as the name. You don't have to actually do a IPM, that is always there in the Kubernetes DNS. But if you want to expose these things outside the cluster, say you actually want to expose this API as an endpoint, that time you have to start declaring external services. But you need to still deploy services to make two groups of pods discover each other. So these are the two things that you should mainly focus on. And the other things so I put all the things so that I put the other things so that you just have a general idea of what you would do. So so if we go back to that diagram of what are, yes,
So this kind of cluster state,
yeah,
how is this different from a traditional MapReduce? MapReduce is more computation.
yeah.
But what is the difference here? You said there's no OS and there's VMs.
There are
So the compute capability, is it the same?
You can there you can provision MapReduce on Kubernetes is for general purpose compute. Right. So you can provision anything you want on it. Like how the master, so you have like, can you repeat? I kind of.
So the construction is the master has the orchestrator, it has the
Yeah.
networks, it decides what consideration is done at which nodes.
Yeah.
If a node goes down,
Yeah.
it knows where else to pick up the data from.
Yeah.
So effectively that's the same as a MapReduce
Yeah.
thing, except that the MapReduce is only for computation.
Yeah. Yeah.
So is this pretty much the same construct or concept, or it's just for separating the modes of applications? So if you are
This is probably closer to Biswas than this.
Yeah.
This is closer to Biswas, Apache Biswas than this to, because your MapReduce thing will only do the management and orchestration for one run of the job.
Yeah.
Because not running like forever and monitoring the entire infrastructure.
Right.
This is entire infrastructure management.
Yeah, it is. Yeah, that would be the thing. That, like, you can compare it, but that is more for a very specific use case. This is like very, this is like very general purpose. I can provision. Say, if you want to provision a Hadoop cluster, you can do that on Kubernetes also. Right? Yeah.
What are the stateful databases?
So okay. These are like. So remember I said that the controller is actually in charge of moving your pods to the physical hardware, right? So if you have applications that are holding state within themselves, this can be problematic, right? It's generally really good for our application servers which are not holding state, right? Our state is actually in the database. So our application servers are really free to move around as much as they want. But if I kind of move around my database, like it can create problems. So stateful sets is a solution which these guys have built to kind of help deal with that. And I don't want to discuss that because it is very confusing if I do both things simultaneously. But I would suggest not to look at stateful sets until you're kind of like comfortable with doing application and like just doing a simple pod deployment. And like even we did that. Like the way that we kind of built up the capability for starting to do stateful sets is that we kind of kept so because Kubernetes is just another platform, it can still talk to all your data. Like we kept our databases running on RDS and things, and we kind of just use Kubernetes to start doing all the application servers, right? And so you can work with that and kind of build up to stateful sets. What stateful sets will let you do is say like you're running a clustered MongoDB, right? Like for the Mongo nodes to discover each other, they kind of need to have sticky names, right? Like you need to be Mongo 0, Mongo 1, and these guys are allowed to talk to each other. So what would happen if you allowed them to just be orchestrated by Kubernetes is suddenly your Mongo 1 has disappeared and it's become renamed to like Mongo 37 or something because you don't have control on this. You cannot actually tell the orchestrator to not move your pods. Like as you're not allowed to do that. It will not actually relinquish that control. Because doing that would mean that it cannot guarantee that the physical hardware is it is able to control your physical hardware. Right? So you kind of relinquish that control to Kubernetes, but you get the benefit that it will do a lot of the things for you. Right? So what I was coming back to was this thing, right? So these things would look like pods, right? This thing would probably look like a stateful set, right? This entire group would be exposed via a service, right? And you can declare these for each of your things, and this is basically how your deployment would look like in Kubernetes.
This diagram takes care of the auto scaling services.
Yes, no. There are two types of scaling in Kubernetes, right? One is that you either need more physical nodes or you need more containers, right? So there is a cluster auto scaling tool which will actually there is a
Dependent. You need more containers, and if you don't have those, you need more nodes.
so you might be so generally one of the things is like when we're running like EC2 machines or VMs and stuff, like one common thing like if you see is that happens is like we kind of run them a bit over provisioned or or when like or mistakenly under provisioned, and they're not actually being utilized to their full capacity, right? Like if we're not kind of like and Amazon is kind of charging us for it, so like not utilizing your entire compute resource ends up being like something that can be used as a cost, as a better cost saving. But so what Kubernetes will do is actually it will make sure that it is packing as many containers as it needs to make this thing stable, right? Like, and it will not just like and if it sees that like if it sees that all your containers can fit in 2 machines, it will not try to run a third physical node. Right? And if you are running 3 physical nodes, it will actually move your containers to the to those 2 physical nodes and downscale to 2 physical. So it handles distributing your containers.
There's an integration between EC2 and Kubernetes.
Yes, you can. So you can do that. Like so on AWS, there are 2 ways to do it, right? Like I mean, there are probably multiple ways. There is EKS, right? Like that is Amazon's like container as a managed container service and managed Kubernetes service. And the thing that we use is there's this thing called Kops. It's a library for provisioning Kubernetes clusters on EC2. Right. So that is also that also follows the same concepts as Kubernetes, and you kind of can declare your clusters in that like same immutable format as you would. Okay. So yeah, so like if you want to kind of like get started, like I would suggest like you focus on these 2 things, pods and services. And like if you so there is something called config maps which allows you to put in configurations onto the cluster, because configurations are also just resources to Kubernetes. And if you kind of do these 3 things, you should be able to see like if you just do the 2 things, pods and services, you should be able to get an entire service running on Kubernetes. Config maps are probably enough for you to, these 3 things are probably enough for you to separate out multiple environments, right? Because you can manage configuration for staging, production, testing. And so there is this website called catacoda.com, right? Which kind of, so I would really suggest that you guys look at this. Like, this website basically has a lot of tutorials on doing things on Kubernetes and containers in general. And like I'll share my slides sometime, but I kind of shared the one which is like really easy to get started with, and you don't even have to install anything. You can kind of run everything within the Catacoda environment, and it will do everything. It will provision a Kubernetes cluster. You can play around with it, do all sorts of things. Right? So I would really suggest looking into that. And yeah, so like so what I'll try to do is like so now we'll kind of like do a demo, right? Like I'll do a demo and we'll run through some examples of what Kubernetes code would look like, right? So what we have is like I was kind of doing this last night, so I didn't have like too much time to finish everything, but I got a tutorial application from somewhere, and I'll kind of run through what exactly is this application doing. So so this is basically a very simple bookshelf application. It is running a Postgres database. It is running a Flask server, and there is a front-end client written in Vue.js, right? And what we want to do is kind of like we kind of want to deploy these things onto Kubernetes, right? So so this server application, which is just a very simple simple Python application running Flask, connecting to something, and so so there is this thing called the Docker file, which defines how we are containerizing the application, right? So if you see what the Docker file will generally look like, is you start with a base image, right? This is the image that is saying like start this image with Python 3.7 installed, and run these steps. Run these steps to make sure run these steps to make the container. So if you run these, like if you execute this Docker file, it will create an image for with whatever instructions are given here, right? So if you see the things that it's trying to do, it is like copying the requirements file from this repository here, running installation, and then finally it is copying over the source code. It is copying over the source code of the application into the container. So, uh,
Repository for the basic image.
uh,
Others there is. So basic image, how do you get it? You put it from registry.
so there is something called the Docker registry, right? There is one. There is one basic. So there is one that is always available called the Docker Hub. Like and what you'll probably do for your organization is probably host a private Docker Hub for images that you want to do for your own. Right. So what we do, so when you declare things like this, like from Python 3.7, this is looking for this image in the, it will actually look in your local Docker registry, and then if it doesn't find it in your local registry, it will look in the global registry that has been defined.
This will be done for every concept you use.
This will be done for every, so this is the container part, right? This will be done for every time you're trying to build a container. Right? And so what we do is like after, so even the, so Kubernetes itself will not actually build your image, right? What you will do is like you kind of run this code to make the image, push that image to a Docker hub somewhere, and then Kubernetes will pull from that every time. So Uh, so, so after say this Docker hub, say after this container has been made, so it will.
What is that?
So if you see what it is saying is like in this. Uh, so this is the okay. So I'll just run through this quickly. So this is like it's saying install Python, install the package which has Python 3.7 installed itself. Right? Run the apt get things to update that image with the latest version of things. This is not always a great idea, but that's what this person has decided to do. And then it's decided to set the working directory as this thing. And this is the scope of the container right now, right? So the container is running in its, so the container has its own namespace, right? So this is like within the container, there is a slash root, there is a root location, and it's declaring that from root location, user source app is where the working directory of the container will be. And then it's just saying, when it's doing so, these commands which you see in big, like these big caps lock commands, are Docker commands. Right? They're actually declarations which you're giving to Docker to what to do. So when it's saying copy, right, it's saying that like wherever I'm running my Docker build from that location, copy the from here, copy this requirements file into this containers user app, src app folder. Uh, and because I've set the working directory as user source app, if I run pip install, it is running with this as the base directory. Right? And similarly, it is saying copy over the entry point assets. So there is an entry point assets file here. It's copying that over. And here it's saying copy everything into user source app. So it's basically, if you see, this is the folder, like there's project API. So it is going to copy this entire thing into the container, right? And then it's just trying to run whatever is in the entry point essence. It's just trying to connect to, okay, it's just trying to run Junior. So now, once you have this container, so I can show what that would look like. So, uh, so that would generally just be so it's kind of just running the build, and it will tell me what its stack it has, whatever that is. Okay, we'll let that complete while I keep going. So now after this image has been built and it has been pushed to wherever the Kubernetes, to the common Docker hub which you can access. Now you can start doing your Kubernetes things, right? So remember we said that like since everything is immutable, you can kind of declare your deployments in like using these things called manifests. The Kubernetes manifests. They're just YAML files that are telling how exactly to execute uh, execute the thing. So deployment is basically your most basic thing that we're trying to run a pod. And what we're saying is run this. So what this spec is saying is like run it as one replica and run this container which is containing this image. And this is the image that you are actually building and pushing over there from that Docker file. Give these environment variables, pick up this value from this config map or secret, and and this is the spec for running your container. Right? So now, if you give this to the Kubernetes orchestrator, it will try to make sure that the cluster state is looking like this, right? So let's see that. Okay, so our image got built. Right? So this thing got built. Oh, okay, I have this. So you can like let's just make let's make this thing run hash.
You can use the image ID.
Yeah. Okay, fine. It's trying to look for Postgres, which it will not find. But you can also like use this to kind of run your basic. You can also since every Docker image is just another thing, you can also do it. How do I run a command and start? We'll get to okay, that demo didn't go really well, but we'll get to the Kubernetes part.
You can like skip to the end,
Yeah. So we're over time.
Yeah.
Okay. So I'm kind of running a Minikube cluster in my local machine, which is a way to run it's a way to run Kubernetes on your local machine, and this is it. The things you do here are mostly identical to what you would do to a stage or production setting. Right? So it generally gives you this dashboard where you can see how your entire how things are running. Right now, like there's only one node, and there's only one physical node which is running nothing, and we can start provisioning some things. So I kind of just provision the entire thing. So this thing is so what I did right now was that like I kind of just ran all the manifests which have been defined in this Kubernetes folder, right? And you just have to actually so the thing because this whole thing is immutable. If I apply it again, so if you see the first time I applied it, it created all these deployments. If I apply it again, it will just give me that nothing in these things have changed. So it's just kind of skipped everything because it already knows that this is the configuration that it's trying to get.
Can you look into the secret.yaml file?
Yeah.
How are you securing the password?
So,
I think we can like move the questions up to the end.
These are the encrypted user ID password.
This you should not commit to your the secrets. You should not commit like this to your repository, but you can basically apply this manifest, and this will actually make the secret opaque on the cluster. Like if someone is trying to look into your cluster, they will not be able to fetch the things directly.
This file does not go to the production environment.
Like it goes in some, it can go into your cluster. You should mostly not commit this into your code base, because then it's apparent visible in your code base. So what we did was like I ran the entire deployment, right? So it's declared to run 3 pods, like one for Postgres, one for Flask, and one for the Vue application, and I've made this entire thing visible on like one ingress node, which is so the service which is exposing the Flask service would look like this. Like it's saying that this is a Flask service. Select this pod which has been named Flask, and expose the port 5000 as port 5000. Right. And then additionally for this, we've also declared a ingress for the entire cluster, which is saying that whenever you hit this host, hello.world, if the path is this, redirect to the Vue service with on port 8080. If you hit this /books, redirect to the Flask service with port 5000. So this is helping you control how traffic is coming into your controller itself. Right. So what will happen when we do this is that the entire, like, it's kind of launched my containerized front end application, and this is actually talking to that same backend, and you can see traffic. You can now, yeah. So this is like the most basic thing for the demo, and if you want to scale up, you can now start scaling. Like you can scale your thing if you want. Like say I want my Flask servers to scale up to 2 replicas. This will just do it, and in my Kubernetes dashboard, it should show that my Flask is running two copies of the container. And so you have another thing called the horizontal pod autoscaler, which can do this on the basis of metrics that it's getting. But you can also just scale up and down by declaring those things directly. Right? Yeah, so this was really fast, but like, did any questions? Like,
I have a question, maybe we can take it offline.
okay.
So each of these Kubernetes components have applications in themselves.
Yes.
And considering that this is a CNCF graduate product, what are Kubernetes applications characteristics in a network function? Like what are the gaps here, trade-offs?
Okay. Interesting. I don't actually. Not sure. So it's not running in a like it's not running in slaveless, like it's not running in masterless mode, right? So I don't know if you'll ever get like
the
a
orchestrator is here and the scheduler goes on the other side of the network application.
So I'm not sure if that is actually going to, like, because like you have masters and you have slaves, right? So not sure what will happen if there's split brain in the masters. But that can happen. I'm not sure if that can happen. I think.
So master, I mean, network partition isn't something that you can say no.
No, I know that network partitions can happen, but basically, if you have the master slave thing, like if a slave is not visible, like the slaves don't have to be visible to each other. But if the slave is not visible to the master, it's effectively like the master thinks this is down. Right? So,
I mean, are there multiple masters?
yeah, so there are multiple masters, which is why I'm thinking what happens when you have multiple masters. I've not actually looked at
My
that.
second question is not about this vulnerability testing function.
Why?
You earlier mentioned that you set up a separate environment for this local test matching.
Yeah.
You load tests and form tests.
Yeah.
Right? But the environment is the
There were some load tests that we weren't like on. So there were some things that we weren't comfortable at doing it from, right? And like sometimes just that is like we're not going to be allowed to take that risk. So that's
You try to do in production, if some guy you shoot in your production environment, they can capture it. So that's the thing. So let's say you got a hyperscaling let's say your employee will be there. He captures everything. That's what we get in this running this in the production.
load test data is any traffic. You can capture that.
No. Okay.
so I mean so when we were doing it, we didn't actually have the Kubernetes setup ready. So that time we did do a load test on production. But it was not a risk that we were super like happy to take. Like, we rather want to be able to provision that.
You can do that when your peak traffic is not. That is the morning 3:30 to 6:30.
But then it becomes that thing that I need to wake up my developers 3:30 to 6:30 every month.
Developer sometimes we are doing light out anyway.
So I mean, generally we don't want people to stay awake.
Ready for my strike.
Generally we don't want people to stay awake late night because of a job.
Sleep in the morning.
So I mean, there are solutions which, like generally the rough principle is like if your developers need to stay awake late night to do things, you probably need to fix the way you work because like they really shouldn't have.
Maybe I will tell you. Half of my team work only in night.
I don't know. That's
Half of the team work in day. We meet only in the evening time.
I mean, even we do that, but we have to. But it's not an environment we like to keep because if people are not productive.
You are assuming that your development team and load testing team need to be same. But in our case, automation test team is very different.
Yes.
So they take care of things whenever they want to take care of things. They don't really bother about whether developer is there or not there.
So I mean, we also want environments to be safe, right? We kind of want so for example, we want the testing team to have full freedom. Like, if we give them a separate environment, they have full freedom to break everything that they want and point it out to us. Right? Instead, like if they break something weird in production, then we're stuck like, okay, we have to figure out how to fix what they just broken.
But in load test, they are not really deploying anything on. So what they can do? They can only bring the server down because of overload. That's all.
But depends. There can be like you can create situations where suddenly everyone's like suppose the load test brings down your
It
service.
can bring denial of service attack at the first. In the worst case, that is what will happen.
Yes. And that can be really bad if everyone like if you're not able to recover.
If it is in the peak hour, then it is bad.
But it might be that you do it on off peak hours and you're not able to recover that.
You work for a
You will
failed
reset.
company.
You will reset.